Good morning. My name is Greg Thane. I'm a developer here at the Center for High Throughput Computing, and today I want to talk about configuration. Specifically, I want to talk about how we can juggle configuration across all nodes in HTCondor pool without going crazy or breaking your pool. This is an advanced administrator's talk. I assume that you know the basics of how HTCondor works, its architecture, and its configuration. But in this talk, we'll give you some advanced techniques for efficiently and easily managing a large variety of different configurations across a wide variety of nodes in your Condor pool. So let's dive right in. I'm going to start out by giving you a review of the syntax and semantics of the HTCondor configuration language. After that, I'll discuss about how this language gives you options in different ways to set up the configuration of your pool. Finally, we'll go into a deep dive in one of those options and talk about how the CHTC itself uses this language to manage our own pool and the requirements and unique needs that we have, and how we use the Condor configuration language to optimize the management and control of our pool. So the HTCondor configuration language has grown organically over time. It's a language to parse and query both config and submit files. Now, the same language, it turns out, is also used for the Condor submit language. We won't be talking about that today, but pretty much all the tips and tricks and syntax and semantics that we will talk about in config also apply to submit. This language, because it's grown organically, is a little bit quirky, and it does a lot of kind of unusual things. So be prepared as we take a deep dive into this language to see some amazing and perhaps terrifying things. The primary thing you'll see in the submit language is key value pairs, where we have a key, which is a case insensitive alphanumeric key, followed by an equal, optionally round space, and then some value. And although the key is case insensitive, by convention, we usually have these things in uppercase, where a multi-word key is separated by an underscore. But this is just a convention. You can have camel case or lowercase or what you want. But the standard Condor knobs, you'll usually see all uppercase. Now, an important thing about the value is that, at least to the configuration system, the value is not typed. It's just a string of bytes. Now, whatever may use this value may assign or require a certain type or a certain format to it, but the config system itself does not know that. It just sees it as a sequence of bytes. And of course, values can be expanded and refer to other keys with the $open paren syntax, which we'll go into a bit more later. But as key equals value is not the only thing that can be in a config file. You can also have statements like if and include. And the thing about statements is statements are evaluated immediately as they're seen, whereas keys are loaded into a key value store, a hash table, if you will, whereas the statements are executed almost immediately. So the submit files or the config files are loaded immediately into a key value store that is later queried. It can be queried by the daemons that run this, like the sked or the startd. It can be queried by Condor tools like Condor config val. But all these keys are stored in memory, whether or not they have a meaning to Condor or not. Statements, however, are executed as the file is read. Now, behind the key value store in memory is a separate key value store that's in the program memory of all the daemons. And this contains the defaults. We often call this informally the param table. So this is the way in which if a configuration value is not specified, a default value can be specified for it by the system. Here's an example of what a config file might look like. This should be familiar to everyone here. A third kind of entry in the config file is, of course, a comment, which is a hash that starts at the beginning of a line. Note that because the values are not typed, a comment cannot go at the end of a value. So the hash that introduces a comment has to start a line. Now, because, as we said, keys are case insensitive, log and log define the same thing here. And if you need to cross a line, just like in C, a backslash at the end of the line serves as a line continuation. And the values will be macro substituted if you use the $open paren syntax. And we use this extensively throughout the default Condor configuration. For example, we define a key, that's sbin, the directory in which the server binaries are stored. And then we refer to that when we name the path to all our server binaries, like the schd. So we say schd here is $sbin/contra schd, where sbin is expanded to the directory where the server binaries are held. Now, the last definition of a key wins. So in this case, if we say a equals 1 and b equals $A and a equals 2, then both a and b will evaluate to 2 because the value of the second assignment to a will overwrite the first one before the expansion occurs, because the substitution happens at the time they're actually used. Now, self-references are very commonly used. For example, in this line here, a equals $A stuff is the canonical way to append to the a variable. And this is used all over the place in Condor, and this is just a pattern that you'll see again and again. Circular references, however, are not allowed. Now what will happen is eventually Condor will detect this by detecting that too many expansions have been done, and the daemon will exit. So be very careful with this, because if you give an invalid configuration, you can cause your machine or your whole pool even to break, and it'll break with a very obscure error message. The Condor config val tool will detect this as well, assuming it applies to the Condor config val, but be careful with circular references. So the appending works a lot, and it's very commonly used, but be careful with these circular references. Something that's used, I think, not as often as it could be is substitution with the default. And this is a lot like the bash syntax, where you have $key : default. And in that case, if the key is undefined, the default value is substituted in. And I would encourage administrators to use this perhaps more often than they do. Now, as I said, the value is untyped, or the type is unknown to the Condor configuration. In many cases, the tool or the daemon that uses the key is expecting a class add expression in the class add language, but that's not a feature of the config system. That's a feature of the daemon that's using it itself. Now, in general, and this is not an absolute truth, but in general, most values that are intended to be numeric values tend to be class add expressions. So for example, num slots or num CPUs is evaluated as a class add expression. And the way you can tell for sure is if you look up the definition in the manual, that's HTCondor.readthedocs.io, the definition in the manual of the knob will say something to the effect of, this is evaluated in the context of the job add and the slot add, or some of the words that this is evaluated. And that means that this can be a class add expression and not just a literal. Unlike most numeric values, string values, however, are generally not evaluated. So for example, in the start D, there's a config val called execute, which is the root directory of the scratch directory for jobs. And that needs to be a path name or really a string. And even though there are string functions in class adds, by convention or maybe by history, we do not allow those to be class add expressions. And in the manual, it will not say the execute config knob is evaluated in the context of this or that. A relatively new feature in Condor is multi-line values. And these are introduced with the syntax key at equals some terminator, in this case tag. And in this case, the value of the tag will be the lines between the at equal and the terminator. This is a lot like a here script in bash. Primarily, the most common use case of this is in class add maps. It's hard for me to think off the top of my head of many other cases where you'd want a multi-line value. But for those that do, this is a very clean way to do that without those pesky continuation characters. In addition to $open substitution, there are a handful of substitution functions. And these are not class add functions. These are config functions that execute at config time. And these are all of the syntax $, some function name, open paren, and maybe some optional arguments as well. Function names are all uppercase, and some of them have arguments, and some of those arguments can be optional. Now, I don't have time to go into great detail on all of these, but a common one is environment, and that's $env, and this will look up the value from the environment And like a normal lookup, you can also have a default after colon. Now, if the name does not exist in the environment, it will substitute with the string undefined, all uppercase. And some of these substitution functions are here. There's numeric manipulation, there's random choice, and the very powerful $F function, where F is short for file, or maybe file name, with all kinds of sub-options. You can do $FP, FQ, FA, which take the argument and then operate it on it as if it were a file to do a base name or dir name or other canonicalize or other kind of common path expressions. And you can look those up in the manual to get the whole list. In addition to these assignments, there's also statements. And the two most common statements are include and use. And unlike the assignments, these are executed as the value is read. So the include statements, the most common is include : file. And again, that's just like a C macro. It reads the file and it takes the content of the file and inserts it as if you had typed it into the current config file. Now be careful here, because if that file doesn't exist, the configuration process will abort and your daemon will not start up. You're going to work around this by adding include if exists some file, which will read the file only if it exists. And if it does not exist, the configuration will not abort. A more powerful friend of this is include command, which doesn't include the text of a file, but rather runs a program or command and takes the standard output of that and inserts it as if you had typed that in. And remember, the expansion will do the current value, not the final value. And you'll see later how CHTC uses this include command to great effect. Here's an example of using include command, which again is very powerful, but you need to use it carefully, because every daemon and every tool reads the whole configuration by default. So if you have include command unprotected, every time you run condor Q or condor status, you'll be invoking that command. Another thing to be careful about is the command will be run by different users depending on the context in which it's run, different operating system users, that is. So for example, if I'm gthane and I'm running a tool and there's an include command, the command will be run as me. But if the master is running it the first time, it might be running as root, and other daemons might run it as the user condor. So you need to be very careful about security and information hiding and what to do, especially if this command modifies state, say if it writes to a file or things like that. So include command is very powerful, but do be careful when you use it. A sort of special use case is include with cache. If you say include command into file, what will happen is that if that file exists, its contents will be read and included into the configuration. Otherwise, the command will be run and the output will be put into the file, and when that file exists, the text of the file will be put into the current configuration. There's no cache expiry on this. This is like a cache. So we commonly use this for things like glide-in and one-shots and places where we know the configuration is going to get read once, Condor is going to run for a short period of time, and then exit. So again, kind of a bit of a specialized use, but when you need it, you need it. A less common use case is conditionals. This is with if or else if. And this is a very limited set of predicates you can put after it. There's no comparison, there's no complex conditionals, but there are special macros for if that are true or false depending on what daemon or tool you're in. And these are perhaps the most commonly used. So for example, this include command into cache is only run if you're the master. Otherwise, we just include it textually. So this would be one way to only run a command once by the master at startup, perhaps. And once that's run once, all other tools or daemons will just read from the cache and from that one file. So that might be one way you want to avoid excessive running of commands. And one thing to be careful of, and this burns absolutely everyone, is that the condor config vault tool, given a given a key, we'll print the value of the key, or with condur config val-v for verbose. Key name, it'll print the key, its value, and what line of what config file is found on, which can be very convenient. But by default, condur config val reads the static configuration from disk. Now, that may have changed since a daemon started. So if a daemon starts up, reads the configuration, and goes on its merry way, and then you change the configuration, condur config val will see the change configuration, which may be different from the daemon. So there are also options to condur config val we see here with the -daemon name, which will tell condur config val, please do not read the configuration as it exists from disk, but please make a query to this named daemon on the local machine and tell me what it thinks the value of this key is. And that can be different from the value of disk, maybe because you have one of these if is master or if is start D or something like that, or maybe because the configuration has changed since the daemon has started. So do be aware of this gotcha. Another relatively new feature is something we informally call meta-knobs, or what look like use statements. And because we often have a set of configuration values that are related, that all need to be set at the same time, we've developed sort of a macro language, or a meta-knob, that lets you set several knobs, or more than one knob, with one use statement. So the syntax is category, use category, and perhaps with an optional name after that, like use role, person. And there are currently 4 categories: role, feature, policy, and security. And you can query the existence of the meta-knobs with condur config val use followed by the category name. Here are some example tricks and tips for using condur config val. And that's the end of my info dump. So let's move on to how these are applied in the CHTC. So what does CHTC need from configuration? Well, like you, perhaps we have many different types or classes of machines. Maybe we have GPU machines and non-GPU machines, or maybe they're different by owner. Maybe they're machines that are owned by, say, a certain researcher or a certain group and need special consideration or priority based on that. We also change configuration frequently. Now, perhaps more than others, because we're rolling out new versions of code and new examples, but we have a pretty dynamic pool, so we change configuration very frequently. And because we have a lot of students who help us out, we have a lot of different people making configuration changes. And some of these are kind of new to the project and maybe not be as expert as we might otherwise like, and so do occasionally make mistakes that need to be detected and undone. So there are 2 sort of schools of thought on the best way to handle this. The first is to leverage some existing solution. You probably already have some configuration management tool like Chef or Puppet or Ansible or CF Engine or something like that. And the advantage of using this to manage configuration is that you already have it. It's one less system to worry about. You probably already know it. And the idea is that you'd use this tool to generate a bespoke configuration file for each host, depending on your needs. And probably that language is richer than the condur configuration language we just showed you. But so that's one option, which we do see people use. The other option is to lean into these condur native config tools, even though it is a bit of a funny little language, and generate a static set of files where all files for all configurations exist on all the machines. And the condur configuration language and system will pick which subset of those files are needed for any particular machine. In this case, it's easier to see all the configs. So if I'm on machine A, it's possible to see the config of machine B and what might be different there. We find it quicker to mutate and make experiments with. And more importantly, I think there's no 2 language or double evaluation problem. Sometimes when you have a configuration language or a language that generates another language, you get evaluated twice. You always have to be aware of what language you're in. If you want something to be evaluated in the second language, you need to escape or quote it, and that can lead to all kinds of things. So in CHTC, we use the HT native condur config, and there's really 2 big reasons for that. First, there's the dog food argument where we want to test this and experiment with it and make sure that it's correct and sufficient. And by exercising it heavily within the CHTC, we get that time on use. That's so important for making sure we're doing the right thing. And our admins actually prefer it. We give them the choice to some degree, And they feel strongly that this configuration language is the right way to manage a large Condor pool. So let's dive into the overview of how CHTC uses this configuration language. We have many, many config files, at least one per machine, and every machine has its own configuration file that's specific to it, and is named by the name of the machine. And this config file defines the class of the machine and anything that's special or unique to it. And there's a handful of knobs in the global config. But you might ask, what about configuration management? We need to be able to make change to this. So what we do is, we want to be able to roll back. And when we say change management, it's not just important to make a change to go from version n to n+1, but also to quickly go from n+1 back to n. And we need to know who made the change and when and why. And frequently we want to be able to test a configuration on one node without changing it on all the nodes. So sort of the best practice to this we find is gitops. And that is to say, we put the whole set of configuration files in Git. Turns out we don't use GitHub, but rather GitLab, but they're all pretty much the same. And we manage them via a series of Git pull requests. And when the master starts up, what it does is it does a Git pull from a repository and gets the whole hive of files, and then keeps it on disk, because we really don't want CondorQ or any other non-master tool doing this thing. An advantage of this is the master and the startee can advertise in their daemon ad what SHA they're on, so we can quickly verify that the correct or perhaps the expected configuration is in the right place on the right machine. And we can use git blame. And this is a godsend because we can make sure that we know of all the people who can make changes to a given configuration. Git blame will tell us who made what change when. And we've never actually done this, but in theory, if we had a really obscure problem, we could use git bisect to figure out what exactly was going wrong. I think the configuration language is straightforward enough that we'll never need to do this, but it's nice to know you have the power tools in your back pocket if you absolutely need them. So what does this look like in terms of config? Well, first we have to set this kind of obscure knob, master.disable setuid equals false. And by default, what's going on here is that Condor turns off the capability to run setuid binaries in each of its daemons. And this is a security thing, so we don't want any jobs to be able to run a setuid program, because if there was a bug or perhaps a security problem, they could compromise the rest of the Condor system. And that's not just true for jobs, but true for plugins and hooks and all kinds of things. So we just generally disable this in all our daemons from master on down. But because the master has root but runs its include files as Condor from time to time, it needs to sudo to do the git pull. So we have to turn this off, but just for the master. So we still have the protection for the startee and the starter for the jobs and plugins, but we lose a tiny bit of security. But hopefully you've got your master config under control. The next two lines then develop the to lowered version of the host name. We had some headaches early on where differing set of DNS servers gave us different capitalized versions of the same host name that caused no end of problems. So we just reflexively now lowercase the host name. And then we set the local config file to the lowercase version of the hostname.local. So we assume that in Git there's a file name with the hostname.local that has the Condor configuration in it that defines this host's needs. And the git magic follows. So we said we advertise both the git branch we're on and the git head, and we put those in master adders and advertise those. And then in the master, if we are the master, and only if we're the master, we do sudo config sync. And this config sync, which we'll see on the next slide, actually does the git magic. Otherwise, we're on the startee. We run this other script update conf, which just emits the git SHA and git branch. So what does config sync do? Well, it's kind of pseudocode here. There's a shell, but basically it issues a set of git commands, which first start with the git clean. So if anyone has changed any of the configurations, maybe by hand, we blow those away. And then we switch to the branch that we want to be on, and we do a git checkout of the correct branch and a git pull. So we use the git primitives to get us on the right branch and remove any extraneous files. And of course, we use the git rev parse here to figure out what the SHA of our our head is, and we advertise that. And this is very critical. We run this all the time to run a Condor config val-af githead to figure out what SHA we're on to make sure that the configuration is what we expect. So putting this all together, we have one global config file, and all these files are in Git, of course. And that points to, via include, a per node config, and that defines the class of the machine or the type or any specialty. And this may point to one or more files that do further configuration. So for example, we may have common configuration for all our GPU machines or all our machines owned by chemistry or something like that. And we would put that into one file that the specific machine would then include. So as we say, don't just tell me the good news. What are the downsides of this? Well, first of all, it is more complicated. There's kind of a lot going on here. And we have to always be careful when we run include command, because if that exits with non-zero, the daemon will not continue running on. So we have to be very careful and make sure that this complicated set of git commands actually does exit 0 or always leaves the config in a secure, if not a safe place. And perhaps it encourages us to be clever with all this configuration stuff. And clever is not a good word. But in general, we do find that this has allowed us to move fast and undo things. So in conclusion, there is more than one way to juggle configuration files, and this is the way that Condor works, that works for the CHTC. We'd like to hear about how other people do this. Maybe there's other best practices. Maybe there's requirements that we don't see that would cause something else to work better for them. But gitops generally makes us more confident and more willing to make more changes. But maybe that's not a good thing. So with that, I'll leave you. Thank you for your attention, and I hope you have fun configuring Condor.